Now we have something to solve, and that's AC circuit problem 3. And what is the problem all about? Let's see. In an AC circuit, the peak value of the potential difference PD is 180 volts. Calculate the instantaneous potential drop or potential difference when it has reached 1/8 of a second. So let's do that. Quickly, we draw the circuit. It's an AC circuit, isn't it? So we can represent just few items or few components. It doesn't matter, the value is not given, still doesn't matter. So let's just represent it in a diagram, in a simple diagram where we have this, all right? And that solves it. So if we have this shows what we are trying to solve. This is L and this is C. Good. So what are we trying to achieve here? Very simple. They say we should calculate the instantaneous drop, potential drop, when it has reached 1/8 of the second. So let's put our diagram in order. So we have V is equal to V naught sine omega t. Okay? We have I, which is equal to I naught sine omega t. These relations will be made use of as we continue, right? Just pay close attention so they don't miss anything, because this question can throw anyone off balance and make you think. So let's think together. Now what do? We have stated this. That's a good start. So let's first of all find out our V naught. That is the peak value voltage, and we've been given peak value voltage as 180 volts. So we extract it out. So we can start somewhere here. Let's see our V naught solution. We're starting somewhere here, solution, and we're going to solve straight across the board. So V naught from that question is 180 volts. Okay? We don't need to argue this. We don't need to argue this. It's already there. The peak value, the potential difference is this. Alright? But there's something here that say 1/8 of a cycle. One cycle is equal to 360 degrees one time. Okay? So how do we now find 1/8 of a cycle? So one cycle is equivalent to 380 degrees. Sorry, 360 degrees, not 80. 360 degrees. That's one cycle, just one turn. Of course, the angle at the center is always 360 degrees. So one cycle, when an object makes a revolution, that's a complete cycle. It completes 360 degrees. Take notes. So one cycle is that. If one cycle is this, it means that 1/8 of the cycle, 1/8 cycle is equal to 360 degrees all over 8. That's what it means. If we understand it to be this, it implies that 360 degrees all over 8 is going to give us 45 degrees. Somebody might ask, how? Let me explain further. Let's go. That means let's clean this off for you to see how it can be done. 2 divided 360 is going to give us 180 degrees. 2 divided 8 is going to give 4. We move on again. 2 divided 80 is going to give us 90 degrees. And 2 divided 4 is going to give us 2. Of course, the answer is clear now. And finally, 2 divided itself 1. Divide 90 is going to give us 45 degrees. What does this mean? Therefore, it means that 1/8 of the cycle is equal to 45 degrees. Okay? And this represents the speed of that current flow. That means omega t is equal to 45 degrees. So take note. Take note. We have found omega t. Take note. All right? Hey, hold on. Come on, hold on. Before I continue, I hope you have not forgotten. Subscribe. Come on, subscribe. Hit the bell button on for constant notification. Share with your friends. Come on. Share with your friends. Share with your students. Share with your networks. And make learning impactful. Make it reach remote areas. There are students somewhere hidden, somewhere that needs something like this. What can you do for them? Push it to them. Share with them. Encourage them to learn. Thank you for doing that. Thank you so much, my returning subscribers and my new subscribers. Thumbs up for you. As I'm giving me thumbs up, I'm giving you thumbs up as well for being here. Belong to this community, okay? Let's move. Let's continue. We found this. The next thing we need to do is very simple. What we need to do here is now we begin to do some kind of comparison, right? That's what we need to do. We are looking for what? They say calculate the instantaneous potential drop. The instantaneous potential drop, PD, or potential difference. That's what they want us to find, and that is V. The instantaneous potential drop is V. V is the instantaneous potential difference. And that's what we're looking for, right? So we go V is equal to V naught sine omega t. We are halfway solving the problem, almost finished with the problem. We recall again, now V naught has been given us 180 volts, so we substitute without wasting time. And then sine omega t, this omega t has been found as what? 45 degrees. So we substitute once again 45 degrees. And what happens here? Can you see how our step, can you see how we are outlining our step clearly for everyone to understand how this can be resolved? So let's go once again. We have 180 degrees, all right? Sorry, not degrees, that's volts. Sine 45 is time. Sine 45. What do you think it is? It's just 1 over square 2. It's just 1 over square 2. If you want to solve using solid form, okay? Solid form. I'm going to teach solid form next time, but not in this topic. So what do we do here? We need to do some calculation. Some calculation. Let's see. This is interesting. It's becoming more interesting than it used to be in the first place. So what do we do? Very simple. 180 times 1 over root 2. Sub form, root 2, we find the conjugates. Over root 2 again. Can you see that? We have found the conjugate of this 1 over root 2, and that is this. So what do you think will happen? Very simple. That leads us to, look at this. 2 square root 2 times square root 2, of course, will give us just 2. Okay? And then square root 2 times 1 remains, so we have 180 root 2. Please don't mind the fact that I'm squeezing up things over there, but look very closely, you're going to see it's clearly stated there. 180 root 2. How did we get that? Look at it. Root 2 times 1, and we have 180. Okay? That's for this. And how did we arrive at 2? Very simple. Square root 2 times what? Square root 2 will result to what? Root just 2. Just 2. And we have 180 root 2 over what? 2. But that's not the end. That's not the end. So we have to find the potential drop of PD across. The instantaneous PD, VIST, is equal to, look at this. Look at this. 2 divide itself 1, 2 divide 180 is going to give us 90. And we now have 90 root 2. That is the answer. Look at that. Look at just this. Oh my goodness. That is the answer. We have finally arrived at the final answer. All this simple but technical question has taken us from these first steps, all these steps down to the last one, and we have finally succeeded in finding that the instantaneous potential drop or potential difference across an AC circuit of this nature is simply 90 root 2. What do you think? If you want to go further, you can still go further by finding root 2 and multiplying with 90. Whatever it gives you, put it in the comment section. If any of these steps is not clear, put it in the comment section and I'm going to do justice to that. I'll let you go now, but don't forget, subscribe. Come on, some thumbs up. And then put on the bell button for constant notification. Don't forget to share with your friends, students, and networks. I sign out. Are you still there? Be there because I'm going to work the next class where I'm solving problem number 4.